Well, welcome everyone. My name is Gabriel Gasque, and I am Head of Outreach at Protocols.io. It's really a pleasure to be here presenting this webinar, this introduction webinar to all of you. Before I start, let me introduce myself. I have a background in experimental neuroscience with doctoral studies and postdoctoral training. And before joining Protocols.io as head of outreach, a little bit over 2 years ago, I was an editor in PLOS Biology, the flagship journal of the Public Library of Science. So I consider myself a scientist as well as an advocate for open science, experimental reproducibility, and research integrity. Before we begin, I would like to acknowledge that the main offices of Protocols.io is located in Berkeley, California, the ancestral and unceded land of the Ohlone people. And we recognize that we have benefited from the use and occupation of this land. Consistent with our values of diversity, equity, and inclusion, we have a responsibility to acknowledge this fact. We also recognize that the Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. I would also like to share some housekeeping information with you before we delve into the main content of the presentation. As I mentioned before, I am recording this presentation and I will share the recording and the slide deck with all registered participants. Also, closed captioning has been enabled, so feel free to use it. I will speak for some 40 to 45 minutes, leaving at the end some time for questions. But you can start typing those questions at any moment in the chat or in the Q&A window of Zoom. Finally, well, this is an introduction to Protocols.io. You can find upcoming, more advanced webinars by visiting protocols.io/webinars. The URL is at the bottom of this slide. And you can also request at any time for free a one-to-one demo at protocols.io/help/demo. And you can also find the URL at the bottom of the slide. Now, this is the agenda for today's presentation. I will go over some of the more general points in terms of the motivations for creating Protocols.io, what our mission is, and how our platform and tools can make your work easier and faster, both in the research lab and in the classroom, as well as to increase the reproducibility both inside and outside your own laboratory. But let's begin with what Protocols.io is. So Protocols.io is on one hand a virtual platform for the collaborative development, sharing, organization, and publication of detailed, up-to-date, and reproducible experimental protocols, research protocols in general. And on the other hand, it is an open access repository for the publications of these protocols before, during, and after publication of a research article. Protocols.io was launched in 2014. We currently have over 189,000 registered users who have created over 18,000 public protocols and over 64,000 private protocols. The public protocols are all open access, which means they are fully searchable and free to read, use, and reuse. And last year alone, our public protocols had over 2.5 million readers. Now, we have collected a series of tweets that comment on the difficulties and frustrations of trying to replicate previously published research. And as you can read in this example that comes from the field of physics, Daniel goes from reference to reference, trying to understand how certain devices used in a paper from 2017 were fabricated. And when Daniel finally reaches the original publication from 2009, it simply says devices were fabricated with conventional methods. And that's all the information he gets. So this is just an example that highlights a widespread problem. That is very often the information reported or included in the materials and methods sections of published articles is insufficient to allow readers to understand what was done and to reproduce the experiments. As part of the background on why we created protocols.io, we also like to talk about the Cancer Biology Reproducibility Project, which was a $1.5 million initiative coordinated by the Center for Open Science and by Science Exchange with the goal of trying to independently replicate almost 200 experiments from about 50 high-profile papers on cancer biology. What the Reproducibility Project researchers discovered very soon after the project began is that it is very difficult to replicate previously published work. There are several reasons why this is the case, but one of them is that the original researchers didn't document in their articles with enough detail what they did and how they did it. So what you see on the screen right now is the Center for Open Science website that summarizes some of the results of the Cancer Biology Reproducibility Project. And as you can see, of the 193 experiments that they tried to replicate from 53 articles, 0% of the protocols, 0% were completely described, which made it impossible to reproduce them without contacting the original authors. Equally striking, when researchers from the Reproducibility Project contacted the original authors, they also discovered that these did not always could tell how exactly their own experiments had been done. Therefore, the problem of lack of reproducibility goes beyond the lack of adequate reporting in published articles, but also highlights deficiencies in the way researchers keep record of their own experimental protocols for housekeeping. This is caused, among other reasons, because people move from labs. Students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. And traditional paper notebooks can be easily damaged, misplaced, and lost, and are difficult to search to find the most up-to-date version of a protocol. Therefore, we thought that a cloud-based system for the proper development, preservation, and publication of detailed experimental protocols was needed. Generally speaking, protocols.io comes in two flavors. We have a completely free open access repository, which provides unlimited publishing of protocols. Each of these public protocols will receive a unique digital object identifier, or DOI, making them permanent and citable. It is thus free to create an account in protocols.io and to publish an unlimited number of protocols. Because the repository is open access, it is equally free to come and read, use, and reuse these public protocols. We also have premium accounts that offer everything the free plan offers, plus an unlimited number of private protocols and private workspaces, premium training, and for the institutional accounts, a free protocol import service. If you are interested, you can find more details about our plans at protocols.io/plans/academia, and I will explain later on what workspaces are and how the protocol import service works. Some of you might already have an institutional premium account if your university is a partner of protocols.io. You can check this list by going to protocols.io/for institution and search for your organization in the menu as I am showing you in this movie. But let's discuss why we think it is productive, time-saving, and rewarding to create, share, and publish detailed experimental protocols in addition to fostering reproducibility. The key message that I want to convey is that practicing open science, including open methods, is beneficial for the practitioner as much as it is for the extended research community. But let me begin by showing how the protocols created and published in protocols.io go beyond what a traditional static PDF offers. These protocols are live, dynamic, and interactive, yet persistent and citable. So I'm going to open one of our public protocols created in the platform and published in the open access repository for you to see. Now, all the functionality that I will be showing applies as well for private protocols. Everything that you create in protocols.io starts privately, and you will have to take an action to make them public. So I'm going to open this protocol. Because this protocol has been published, it has received a DOI, which makes it both persistent and citable. The protocol itself is written in a detailed recipe-like step-by-step fashion. It can be supplemented with images, pictures, and even videos that you can play while looking at the protocol. Different sections of the protocol can be coded in different colors, creating a table of content that can be navigated. The protocol, it's a dynamic and interactive document. Any reader can come, select this plus bubble, and add a comment or ask a question, and the authors of the protocol will be notified, and they can come back and respond to that comment and question here in the platform. As I mentioned before, it can be supplemented with images, tables, videos, pictures. If the authors improve the protocol, they can generate different versions, and the reader will be notified that new versions exist, as you probably remember from when I opened the protocol at the first time. I can also compare two versions of the protocol side by side to see what the changes are. If I think this protocol is useful for my research, but might need some tweaking for my own conditions, my own, let's say, mouse line or bacterial strain or antibody or equipment, I can create my own editable fork or copy to optimize the protocol. And finally, every protocol comes with a run button, which allows me to follow the protocol as I perform the experiment. So as I do the experiment, I can mark each step as done. If I want to add a comment, upload an image, if there is a result in this experiment, I can do so. There are integrated timers as well in the protocol, and the computer or tablet will beep when the time runs out. And eventually, I can finish or save the protocol as an independent record. And I can do this while I am optimizing the protocol or once I have established a SOP. But let me go back to the presentation. And while there's a historical bias in favor of protocols in biomedicine, the platform itself is agnostic to the research topic, and researchers have begun to use it to develop, share, and publish protocols beyond the molecular biology laboratory. In this slide, I show you 7 exemplary protocols in the areas of electronics, computational sciences, clinical research, systematic reviews and meta-analysis, environmental sciences, archaeology, and social sciences. But you can extrapolate the idea to any specific area of research. I'm going to just open one as an example. Again, this is a protocol in archaeology that describes a method to make diagrams of lithic tools. And as I mentioned before, it is a detailed recipe-like step-by-step protocol supplemented with images, pictures. There are several sections in the protocol. It is interactive because it accepts comments, and it can be copied or forked, run, and the authors have versioned the protocol as the protocol has improved. Now, let's really discuss why we think it is rewarding to create and publish these detailed experimental protocols. So, not necessarily in order of importance, but a first advantage of making your methods public is that by using specialized repositories to publish these protocols, you are increasing the chances that they will be discovered and reused, which should lead to more credit and recognition. And I would like to use an example here taken from X, previously known as Twitter. So you can see a tweet here from a researcher who was looking for a protocol for RNA extraction from primary cortical neurons in culture. Someone answered this tweet and recommended a protocol that is in protocols.io. But this protocol is actually part of a paper that was published in the journal GigaScience. Now, the paper is about a fish parasite. So the chances of researchers working on primary cortical neurons in culture finding a paper on a fish parasite as a means of finding a method that would work for them seem really slim. But because the protocol was published independently in a specialized repository, it made the method more discoverable and increased the chances of people reusing it. And once a protocol has been published, it has a tab called Metrics that shows all the use and traffic to and the protocol, including the number of views, bookmarks, exports, copies, comments, and citations that the protocol has received. Another reason to make your protocols, research protocols, public is to guarantee preservation and to facilitate seamless continuity of the work inside your own research group. As we have discussed, a large fraction of a lab personnel is floating. Students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. So publishing your protocols makes them persistent citable objects that will be permanently stored in your workspace as well as in the open access repository. And I should mention that all private and public content in protocols.io is mirrored and backed up in Clocks, GitHub, and the Internet Archive. And public sharing of protocols also increases the chances of establishing collaborations, as we have seen cases where researchers report that this is the case. And I would like to show how the common functionality of the platform allows an open, scholarly, and productive discussion between all parties interested in a particular protocol or method. So I'm going to open this protocol. So this is a particularly popular protocol. I'm going to make it bigger so you can see, which has received over 1,300 comments. And if I click the comments, I can see the conversation, the back and forth between readers and users of the protocol and the authors. This is an open, scholarly communication that can potentially lead to collaborations. Managing and publishing your protocols should also simplify your work down the road when the time of submitting and publishing a paper comes. Let me use another example, again taken from X. So we have here Professor Jonathan Kipnis at Washington University in St. Louis, the United States, tweeting and saying, what if labs publish each of their unique methods protocols, and in future papers, instead of rewriting the protocols, we just cite them? And he adds, we waste so much time on methods by saying the same thing differently. And that is exactly what protocols.io is about. You can publish your updated, detailed research protocols in the open access repository, obtain DOIs, and then anyone, you or your colleagues, can cite those protocols. But citing detailed protocols goes beyond saving time by not rewriting methods. Citing and using detailed protocols improves rigor and reproducibility, making your papers more robust and impactful. And that is what the authors of this PLOS Biology paper did. They created and published their protocols in protocols.io, obtaining a citable DOI, which they then included in the materials and methods section, replacing most of the writing. The reader, by following the link, has access to the detailed step-by-step protocol in protocols.io. And a really nice thing about how protocols.io works is that the protocols are versionable, as I have mentioned. So if the authors have updated their protocol since the time of publication, the readers will be notified and can choose to read the protocol as it was published, which is what you see on the screen now, or by following the View the Newer Version link, have access to the most updated version of that protocol. And a fifth point would be that by managing, preserving, and organizing your protocols in protocols.io, you will be complying with the NIH data management and sharing policy, because methods are an integral part of data. And the NIH rigors and reproducibility guidelines also explicitly highlights the need for grant applicants to describe details in their applications, which should be considered by reviewers. And as a bonus, by practicing open science and particularly open methods, you increase reproducibility in the field, which is a present, a gift to your colleagues, to your field. But also, you increase reproducibility and robustness within your own research group, which is a present and a gift to yourself. So, in a push to increase transparency, accountability, and reproducibility, several organizations, including over 500 scientific journals, funding agencies, and educational and research institutions in 3 continents, support and promote the use of protocols.io. Now, let me give you a taste of how the platform looks like and how its different functionality allows you to do everything I listed before. Organize and preserve your work, collaborate, save time, increase your reproducibility, impact, and credit. So protocols.io has 3 main sections: the workspaces, the file manager, and the editor. And I will explain in the next few slides how they relate to each other by using a simple cartoon. So the workspace is where everything happens. It is from this space that you create protocols, organize your work, and collaborate with others. The workspace has a folder that is organized by the file manager. In the file manager, you can use the editor to create protocols. During my explanation on what each of these sections does and how they relate to each other, I will be moving back and forth between them. So if you go to our website, what you see on the screen is the landing page. You can create an account if you have not done so already and log in. You can also log in using Orchid, Facebook, or Google. And once you start a session, the system will ask you to create your first workspace. The system will also ask you if you want to start inviting collaborators to this workspace, but completing step 2 is not mandatory. Once in your workspace, you will have access to the file manager, which is what you see on the screen now empty because this workspace is new. To the left-hand side, you have access to the administration menu of that workspace. And to create a new protocol, you have to select the new button, which will take you to the editor. The file manager will eventually contain, display, and organize the protocols that you have created within that workspace. The file manager supports any file type, so you can bring Excel documents, you can bring Word documents. It helps you archiving, auditing, and exporting because it can connect to Dropbox, OneDrive, and Google Drive, and has been designed with enterprise-grade security and backup functionality. The editor has detailed components, a granular editing history, and allows all changes to be reverted. It also allows the editor concurrent editing by 2 or more collaborators, the same way that 2 or more people can work simultaneously on a Google document. The protocol itself can be written or is written in a step-by-step recipe-like format, as I showed you before, and different sections of the protocol can be coded in different colors. Now, going back to the workspace. This is the space for collaborations. You can invite anyone to join your workspace. It can be a student or postdoc in your group, another faculty member within the same institution, or external collaborators. To invite collaborators, you go to the administration menu in the workspace, as I am showing you in this movie. You select members, and now you can invite people by typing their email address. They will need to have an account in protocols.io to join your workspace, but as I mentioned before, creating accounts is completely free. You can make your workspace public, meaning that it will be searchable and people can request to join, or completely private, which is the default setting. Again, new workspaces, new protocols, everything starts privately. You can also manage the permissions that members of your workspace will have and limit what they can do, such as inviting other members or sharing, publishing, or deleting files from the workspace folder. Workspace members can comment on the protocols you have created and share with them, or ask questions by using the comment functionality that I showed you before. If allowed, these members can also make changes, improvements to the protocols. And as I mentioned before, there is a detailed log of all changes implemented, which can be reverted if needed. Members of a workspace can also create their own protocols or take an existing protocol, make a fork or editable copy, and modify that copy, optimizing it according to their own needs. Now, the platform allows you to compare two versions of the same protocol side by side. As I show you in this movie, so I can easily see what were the changes from the two versions and how the protocol has evolved. And importantly, even if a member of your workspace leaves, because, for example, a student has graduated, the protocols will remain organized, up to date, and available in the file manager. Now, you can also select to print or export your protocols, as I show you in this PDF. Sorry, in this movie, you can export the protocols as a PDF. Which you can then print and have a hard copy at your bench while you are running your protocol. You can also collaborate beyond your workspace by sharing your protocols with specific people via email or by publishing them. So I'm going to open my own account in protocols.io, which is what you see now. You can take any existing protocol and share it beyond the workspace. Sorry, oh, sorry. So I can select a protocol, share it, and I can add collaborators to this document. Once I save the changes, you will see that in this case, 4 people have access to this document, not to my workspace, just to this document. Lenny, Nastia, and Emma can edit the protocol, but Daniel can only see it. And I can change that at any moment. Publishing a protocol will assign to it a DOI, and will allow anyone with an internet connection to search for it and to access it. A published protocol with an assigned DOI is a citable object that can be referenced to in a paper, giving credit to the author's methodological work. The reference will be linked to the protocol in the platform, so the readers will have access to the interactive step-by-step protocol, even if the paper was published behind a paywall, because all of our content is open access. Once the protocol is published, any reader can create a new fork or editable copy and modify the protocol according to their own needs. So in a sense, all public protocols, because they are open access, are templates for further optimization. And the platform will link any forked protocol to the original one. And in this way, everyone maintains unearned credit. So for example, this is a protocol that is a forked version of an original protocol created by somebody else. The platform tells us that the protocol was forked from another protocol, which you can access by following the link. Therefore, all authors get credit for protocol creation and optimization, and the reader has access to the history of changes and evolution of the protocol. Another way to share your protocols and to increase your credit for your method development work is to send your protocols for peer review as standalone methodological papers to PLOS ONE, Nature Protocols, BMC Methods, or Lab Animal. So here you see the options on the platform. And the idea is that your protocol, published in protocols.io independently of peer review, can be submitted to any of these 4 journals for peer review and eventual publication as a methodological paper, which should increase their visibility as well. Now, going back to the workspace, you can create multiple workspaces in your account depending on your research and teaching needs. You can create workspaces for different research projects or to teach different courses. Each workspaces can have different members and contain different protocols and documents, giving you great flexibility for organization. However, I appreciate that some of you or all of you might already have existing digital protocols in other formats like PDFs or Word documents. So in the last 5 minutes or so, I'm going to do a short demo to demonstrate how you can bring these existing protocols into the platform, starting from the easiest and then moving to the most sophisticated way of doing that. So I will show you how to drag and drop protocols, how to attach them to a empty protocol, and how to import steps from a text file. And then I will briefly mention about the import service. So I'm going to stop sharing for a bit. I'm going to reshare my screen. And you should be able to see here is my folder. I'm going to create a new folder for today's demo. This is an empty folder. And here you can see my hard drive that contains some protocol in different formats. So I have a Word document, an Apple Pages, a PDF, and plain text. I'm going to open one of these documents so you see the protocol. You can see here that there is a title, an abstract, and then we have sections and steps. I can take these protocols and just drag them. So this is the easiest and quickest way for you to centralize your protocols and share them immediately with the members of your workspace. You can also take any of these protocols and share them beyond the workspace, as I showed you before. However, because these are not protocols created with the editor, but these are documents in their original format, they are not publishable. So they cannot receive DOIs. The easiest way for you to create a publishable protocol out of any of these existing documents is to use the editor to create a new protocol. You can add a title. In the description tab, you can add an abstract. Adding a title and an abstract to your protocol is important because it will make them more discoverable. Now, the easiest way for you to create a publishable protocol is to attach the existing protocol to this otherwise empty protocol. I can select the protocol that I want to attach, in this case, a PDF document. In the description tab, I can scroll all the way down, and then I can just attach my PDF. Now, if I view my protocol, I will see that there is a title, the abstract, and the protocol itself is attached as a PDF. However, because there are no steps, I cannot use the interactive and dynamic features of the protocol. Nonetheless, I can publish the protocol because it was created with the editor. To create an interactive and dynamic protocol out of an existing document, I go back to the editor. You will see here that there is a function that says insert steps from text. I can select it. Sorry. I'm gonna delete these steps. I apologize. I select insert steps from text. I open the document that contains my steps. I can select the steps that I want to insert. I copy them. And now in select steps from text, let me reload. I paste them here. And now the steps have been added to my protocol. I will delete this again. Now you see that the steps have been transferred from the Word document to my protocol, and now it has become an interactive and dynamic document that accepts comments and can be run from the computer and tablet. And finally, about the import service. So if you go to protocols.io/we enter protocols, you can send us your existing protocols in any format, and we will typeset them for you privately. This service has a cost, but it is free for users and institutions with an institutional license. So in summary, I hope to have provided enough information to persuade you that by practicing open science and open methods, particularly with protocols.io, you can stay organized, collaborate efficiently, save time, increase your impact, and get credit for your method development work. And with that, I will be happy to take some questions. So the question that I have is whether we can add interactive plasmid maps onto the protocol related to gene editing. We don't have a feature for adding interactive uh, plasmid maps, but you can make a video of the process of how to cut or to clone into that plasmid and then embed or attach that video to your protocol. Any other question? I'm going to stop the recording in case somebody wants to ask a question of the record.